Alright, so today we're going to learn 10.3, which is an extension of geometric sequences, and we're going to extend that out to series. So just like yesterday, how we revisited the idea of arithmetic, today we're going to revisit the idea of geometric. So we are on notes on worksheet 7. So who, off the top of their head, it's probably somewhere in your paper here. Do you guys see the geometric sequence formula? I think it's on the next part of your notes. It's this guy right here. So that's the same formula we used a few days ago. We're going to do exactly how we did in the previous lesson, where we're going to just see some unusual and atypical problems involving the sequences themselves. And then we're going to extend that out to how we sum everything together. Now, geometric are interesting because if you look at certain geometric sequences, some of them converge and some of them diverge. So when we get to the series part, we'll have to talk about what we do. All right, so this first question is that new concept of, oh no, it's not. It's not a new concept at all. So geometric sequence, here. Do you guys remember how you find the common ratio? I mean, hopefully you can just kind of look at this and figure out the common ratio. Remember, it's something that you're multiplying by every time. But if you're in a jam, you just take two consecutive terms and you divide the second one by the first one. So like for us, negative 24 over 8 gives you a common ratio of negative 3. So the common ratio is negative 3, and they want the 7th term. So because we're not new to the geometric sequence formula, I'm going to skip the step where we actually write the full general sequence, and let's just figure it out for the 7th term. So it starts with the first term, which is clearly an 8, and then we're going to multiply that by the common ratio, which we just found to be a negative 3. Make sure you get in the habit of putting common ratios in parentheses. They're not always necessary, but here they are. And then to the n minus 1 power. So if you're trying to find the 7th term, that means you have to do the 7 minus 1 power, which, yes, go ahead and call that 6. So on your calculator, please, can you tell me what you get? It's 5,000 something? Okay, 5,832. Cool. So now that we're a little more knowledgeable on geometric sequences, maybe we don't have to go through the arduous process of finding exactly the formula and then going and using the formula like we did on the first part of the homework. So remember how we had arithmetic means yesterday? Today we have geometric means, and they work similarly where you're going to put empty spaces in the sequence. However, since the relationship from hop to hop to hop is not an addition relationship anymore, it's a multiplication relationship, we're going to have to set this up a little differently. So let's take a look at this example in your notes. It says that there are 2 geometric means in between 6 and 162 in that order. So if you think about how many times did you multiply by this common ratio to get to 162, it is 3 times. So the way our setup looks is we start at the number 6, and then we multiplied by some mysterious common ratio, whatever that thing is, and we did it 3 times, right? 1, 2, 3 times. So in math, if you multiply 3 times, we can shorthand that to saying to the 3rd power. And it got you to the number 162. So now your algebra needs to kick in. You're going to divide both sides by 6. And then everyone is either cube rooting, or you might want to get in the habit of doing reciprocal. Whoops, that's not that anymore. What is 162 divided by 6? 27, thank you. Oh, we could probably do that in our head. So the cube root, or the 1/3 power of 27, is 3. Now, just in case it shows up later, do you guys remember that sometimes when you have even roots, like 4th root, 2nd root, 6th root, what else do you have to remember when you take the square root or the 4th root or the 6th root of an algebra equation? Yeah, you're going to have positive and negative possibilities, so just watch out for that in the future. Oh, what do they want though? They said write a sequence. So I think what they mean by that is just to fill in the missing terms. So if we multiplied by 3 each time, 6 times 3 would be an 18. 18 times 3 would be a, thank you. And then if for some reason they wanted the formula, well, that wouldn't really be too hard because we have all the pieces we need. So the sequence formula is 6, the first term, times the common ratio of 3 to the n minus 1 power. All right, moving along. So it says practice, but I think we'll practice together if you don't mind. Oh, fun. That is a very atypical geometric sequence. Can you find the common ratio? And then continue on and find the next 3 terms. Well, maybe you see it and maybe you don't, but remember one way you can find the common ratio is to divide two consecutive terms, the second one divided by the first one. So 2x plus 2 being divided by x plus 1. Now I need your algebra brains to kick in. When you divide rational expressions like this, you need to factor all the polynomials. So like this dude is really 2 times x plus 1 over x plus 1. So the common ratio reduces down to a 2. Now, maybe you were looking at that sequence going, yeah, I saw that. That's cool. If you can find the common ratio without doing the math, that's great. Find the next 3 terms for me, though. So after this guy, if you multiplied everything by a 2, your next term would be an 8x plus 8. And then go again, you'd have a 16x plus 16. And then they want 3 more terms. So 32x plus 32. That was a good time, wasn't it? All right, number 2. Find the first term of the geometric sequence, and then they give you a random clue about the 6th term and the common ratio. So again, keep in mind what the formula looks like. The nth term could be any term. It's just a general statement. And then if you have the first term, you could place it here. And then the common ratio to the n minus 1 power. So if they give me a random clue about the 6th term, I'm going to use this 0.1 as my solution. I don't know the first term, leave it as a variable. And then they went ahead and told you the common ratio is 0.2. And then up in the exponent, it's n minus 1. And remember, we're referring to the solution for the 6th term. So the n is now a 6. So you can call it 6 minus 1 for your notes, but yes, that is a 5. So on your calculator, you're going to need to divide by 0.2 to the 5th power on both sides. Definitely a calculator question. I don't feel like doing that one in my head today or ever. I got 312.5, which if you did math enter and got 25 over 2, is that what it is? Who cares? Because it says, that's a truncated decimal. It's not like you had to round it off. It stops. It's not irrational. All right. Find R. And then they tell me a couple of clues. So first term, that feels important. We're going to use that directly in the formula. And then the 10th term is just that random term that they decided to give me. So I'm going to use the 7,680 as my solution. The first term they flat out said was a 15. And then it's r to the, remember it's n minus 1 power. So since we were working with the 10th term, that's your n. So 10 minus 1 power, better known as the 9th power. So first step in solving this, though, is to divide by 15 on both sides. Little calculator assistance from y'all. What is that? 512 equals r to the 9th power. You can either use the xth root key on your calculator, or you could just simply raise to the 1/9 power. Remember, if you're using an older calculator, that 1/9 power has to be in parentheses. If you have a newer calculator, it understands. What'd you get? Oh, a little 2. How fabulous. And that's all they wanted, r. Moving on. So here's one of those geometric mean, and there's a big typo in the middle of it. It says arithmetic means. A geometric sequence would not have an arithmetic mean. So this was supposed to say the geometric mean. And there's 3 of them between 7 and 567. So that means there's 3 missing terms. But talk to me about how many jumps or hops or whatever you want to call them did you get to, took you to get to 567. 4 jumps, good. So you started at 7, and then you multiplied this mysterious common ratio 4 times. And it got you to an answer of 567. So let's solve. Uh-oh. This time you have an even power. So if you think about, okay, I'm either going to 4th root or I'm going to 1/4 power this. Because it's an even radical, you have to consider the possibility of the ratio not only being a positive answer, but possibly a negative answer. What is the 4th root of 81? 3. So now we have to stop and think. Is it appropriate? Like 3 is definitely good. We know 3 is good. What about -3? If you multiplied this by -3, that would be a -21. And then if you multiplied by -3 again, that'd be a 63. And if you multiplied by -3 again, that would be a, I don't know. What is it? Say it one more time. Negative 189. And then if you multiply by a negative 3 again, do you get positive 567? Okay. So this is a possibility where you could write me two different common ratios in your formula, and they both would be correct. So that was fun. So the big difference there was we took an even root. So you got to go back to your algebraic knowledge of saying, okay, if I took an even root in an algebra equation, the answer could possibly be both positive and negative of whatever I'm getting. All right, some new formulas for you. Remember yesterday I gave you formulas and I said we could also do some of the sequence. That's going to happen again today. So you have to kind of stop and decide when is it appropriate to use some of the sequence, because today it's not appropriate on all the questions. But also, when is it easier to use a formula versus some of the sequence? So if you have a finite geometric series, so it's a geometric sequence that they want you to add up together all the terms from like 1 to a certain specific number. You can use either one of these formulas. So on your formula sheet, I feel like this is the only one they gave you. Can we confirm on that? They don't give you the secondary one? Okay. So just like yesterday, Formula 2 is a derivation of Formula 1 combined with the original geometric sequence formula. Remember how yesterday like we had to go find some mysterious ending term? Same idea. So this is the only one on your formula sheet for finite. Is the infinite geometric sequence on your formula sheet as well? Cool. I don't think this is actually on your test though. So that's the good news. If you have an infinite geometric series, that means they don't tell you an ending spot and they say add up all your terms from 1 to infinity. So that's kind of a weird question at first. You're like, well, how do you add up forever? And the issue is you're allowed to add up forever. Thank you. This is one convenient, so you make that choice. The reason you're allowed to add up some infinite sequences for geometric is if your common ratio is less than 1. The absolute value of the common ratio is less than 1. Because think about if your common ratio is like a half or a third. Your numbers are going to keep getting smaller and smaller and smaller and smaller. They're going to approach 0. They're going to use a new word here. They're going to converge to a limit. And that way, you're going to be able to actually answer it, which sounds really weird, but that's a really big calculus concept. So you can technically say I've added up all the terms from 1 to infinity because it gets to the point where like the differences are so negligible that they can actually give a sum. So if your common ratio is not less than 1, or the absolute value of it is not less than, so if your common ratio is 2, 1.5, you will not be able to do an infinite sequence, guys, because your ratio numbers are just, they're going to get bigger and bigger as the sequence goes on, and you can't add up numbers that just keep growing without bound. Some argue, well, the answer is infinity. Okay, sure, but that's not a concrete answer, right? Infinity is a concept, not necessarily a number. We have this fight in my house. My kids know all about infinity. Isn't that cute? They're 6 and 9. All right, so let's talk about these formulas. This one doesn't look too bad, does it? A sub 1 minus mysterious term times r divided by 1 minus r. Okay. I would only use that sequence or that series formula if you know the beginning and ending term. So kind of like yesterday, if you flat out are told the beginning and ending term, this is a really good formula to be using. But did we say that was the one that they don't give you on the formula sheet? Oh, that is the one they give you. No, that's not the one they give you. Well, that's a bum. Wait. This one they give you. This one. But not this one. Oh. Well, good news. I don't think I'm going to use either of these on the test. Because I'm going to do some of the sequence the whole time. But that's okay. Humor me, all right? This formula here, the second one that is on your formula sheet apparently, this guy. Notice what they don't have anywhere in the formula. It doesn't say the nth term, right? It doesn't say what's your final term. So this formula is actually a little more user-friendly than what we did yesterday, because if I say I want you to add up like the first and the 38th all the way to the 38th term, you don't have to go find the 38th term when you use this formula. So that's nice. But you can only use this term that I'm trying to highlight in blue if you know how to type well on your calculator. So that's usually the issue kids run into, is they don't type this well on their calculator. And then this infinite one is sometimes allowed to be used, but only if it's going to converge. So your common ratio has to be less than 1. Let's see some examples, guys. All right, well, a little bit of a bummer. They don't really tell me anything other than the sequence itself. So they put plus signs in between all the terms, and they want me to sum up the first 12 terms. It would not be smart of me to sit here and write out 12 terms and add them up. That would take me too long on a test. So instead, let's figure out what's going on in this problem. Clearly, the first term is 6. And then if you could maybe find a common ratio for me. And if you're not sure, you could take the second term and divide it by the first term. What'd you get on there? 1.25? Thank you. You're welcome to write that as a 5/4 as a fraction. I'm going to stick with 1.25 for today. So summing up the first 12 terms, I'm going to use the formula that is on your formula sheet, the second one that we were boxing in there last. And it says S, it'll be sub 12, equals, now notice the a sub 1, the first term, is just kind of hanging out in front of the fraction. There's a big set of parentheses around that fraction, and there's no like power outside of the original parentheses. That tells me that a sub 1 can actually sneak up into the numerator with everybody else in the numerator. So when I usually write this down on my paper, what I do is I say parenthesis, and then I throw the 6 in. So basically I'm putting the 6 in the numerator instead of out in front. Now another set of parentheses has to be around your numerator and your denominator. You might want to highlight that in your notes somehow. Right here and right here, you are going to have to know to put an extra set of parentheses around those subtraction problems. That is the most common issue for kids, is they don't use enough parentheses. All right, so I always forget this formula. It's 1 minus the common ratio, which this one doesn't have to be in parentheses, but you might want to just have a habit of always using parentheses there. I'm just throwing that out there. To the nth power, so to the 12th power. Close that parenthesis. I guess in hindsight, I don't really need these outer parentheses, do I? But it's too many parentheses. It's okay. It's not going to hurt your problem. And then you're going to divide it by your denominator, which is 1 minus r, right? So 1 minus, down here, you will never need parentheses around the r. So the parentheses you need for sure are these guys. And then these green ones, you don't need them in this problem, but in an upcoming problem where your common ratio is negative, you most definitely will need them. So for me, because I don't like to have weird rules in my head, I just go always use parentheses there, and then I don't have to think about it. All right, go ahead and type that in for me, guys, very carefully, and I want everyone typing it. And you can give me the gross decimal answer. I think if you try to math enter it, it won't give you a lot of help in the notation that it is currently in. I want to make sure everybody gets this. Well, that is it. That's the full decimal. In this case, yes. Now, because it'll say on the test the exact answer. Here's what I would suggest. If you guys didn't like that and you wanted to write it as a fraction, calculate the numerator and denominator separately, and then, like, by hand divide those, kind of. Like, halfway by hand, I should say. So if you ever are in a jam and you're like, my calculator will not give me a fraction, calculate numerators and denominators as separate problems, and then you figure it out from there, which you guys totally can't. You're in pre-calc. I got faith. The ones on the test, you can just math enter, and it brings it back to a fraction. Got it? Did anyone not get that? Because we got to talk about typing. Okay. Can we all talk about another idea? You know, my favorite thing, the sum of the sequence thing? Well, sum of the sequence makes me very happy because there's less formulas I need to think about. The only thing I would have to think about if I was going to do the sum of the sequence on this question is I would have to program the sequence formula from the original sequence itself. So I already knew it was geometric because they said it's geometric. And then I would type in the general geometric sequence. So it would be 6. I always put a multiplication sign, but you don't need it. Times the r, which is 1.25. And then to the, now this is a little tricky because your calculator is going to do it in like horizontal script instead of like the superscript. So you have to put n-1 in another set of parentheses because of the way it's being typed in. And then remember how it commands you in the calculator, so you don't really have to think really hard. The next thing it wants is the variable, and then they wanted the first 12 terms, so 1 to 12. Can you all just try typing that for me? Humor your teacher today. We should get the right answer too. Yeah. And I don't know about you guys, but I'm thinking, like, I'm envisioning me taking this test, and I just want to be done. And I don't want to run out of time. And I don't want to hem and haw with formulas. And if I know every time I have to do a summation, like sum all the series together, if I know I can do this one every single time, I might just go for this one. Here's the only time you can't use this, if it's recursive. If it's recursive, you're in a bit of a jam, and you got to come up with another way. Okay? So, up to you. Oh, this is fun. Find the sum. That indicates the whole shebang, guys. This is an infinite series. It never ends. But look what's happening. Now just visualize what's going to happen here, guys. You don't even have the common ratio yet. I know they figured it out for you, but can you tell on this next example that they're just going to get smaller and smaller and smaller and converge down to essentially 0? So this is one of those convergent sequences, which means I'm allowed to take an infinite sum. If you want to use the formula, which I would, it's pretty simple. Oh, this is the other time you wouldn't be able to use sum of the sequence. I guess you could, if you put in a gigantic end value. Yeah. It might not be the exact answer, though, so you got to watch out for that, okay? But I don't think I asked you this on the test at all. It might be on your homework, but it's not on your test. I'll double check before we take the test. All right, so they already found my common ratio for me. That was nice. And because it's smaller than 2, or smaller than 1, rather, it's convergent. So they can use this formula where you take the first term, 40, and you divide it by 1 minus this common ratio they just found. Now, if you're typing this in one step on your calculator, remember to use parentheses down there. Some kids say, can I just call that a 0.8? Yeah, you can. So what's 40 divided by 0.8? 50. Did you try to do some of the sequence? Did anybody try to do some of the sequence with a really large one? Go ahead, try. Put like a gigantic number in your end value. See what happens. I'm curious. So we'd have to do 40 times 0.2 to the n minus 1 power. And then 1 to something really large. I see you typing a lot of 9s. That's smart. Oh, but that's okay. It's still big. Huh? You didn't get any number? It's thinking? It's thinking so much we killed our calculators? It didn't like that, did it? Ooh. Then let's not do that. Thanks for playing the game, though. Okay, so if for some reason in your homework you have an infinite sequence that you're supposed to add up, and it is convergent, maybe just use that formula. I mean, I'll be honest, guys, that's a real nice formula. And I know this formula shows up in your calc future, so maybe this is a good one to get used to. All right, let's practice, y'all. Look at this sequence. What's going on here? Now, they didn't tell me what's happening at all. It could be arithmetic, it could be geometric, it could be nothing I know about. What do you think, guys? What's happening each time? We're definitely not adding a term each time, so is it geometric? Yeah, what are you multiplying by each time? Yes. So the common ratio is 4, which if you're going to use sum of the sequence, your sequence itself is going to be -1 times 4 to the n minus 1 power. So I would like you to add up the first 7 terms. So if you are a fan of this new formula, not the infinite one, because this is not an infinite guy, but the other one, you would have to type very carefully in your calculator, -1, and then make sure this next part is in parentheses. 1 minus, you don't need to have parentheses around the 4 to the 7th power, but you do need parentheses there, divided by 1 minus 4, which, yes, that is -3. So if you'd rather just type -3, that's fine. So the optional parentheses that you guys could have are right here around the 4, just for the sake of habit. You don't need them there. The only time you need parentheses around your base is if your base is something negative or a fraction. Anywho, that comes out beautiful, and if you chose to do some of the sequence, you also get the same beautiful answer. So some of the sequence people are typing -1 times, you don't really need parentheses here, but 4. This time you do need parentheses around the n minus 1, comma n, comma 1, comma 7. Either way, what do we get, y'all? Negative 5461. Awesome. Make sure you're typing and you are indeed getting one of those methods to give you that answer. I know sometimes people are just kind of watching going, yeah, I can totally type. I'd hate for you to find out on your test you can't type. That's bad. And seniors, remember, even though you might not be taking this full test, this is like the whole back page of the part 2 of your slow test. All right, find the sum of the geometric series. The first term is 8, and then this mysterious nth term, whatever it is 0.03125, and the common ratio is 1/4. Now, where's that other formula at? Yeah, I know it's not on your formula sheet. But do you remember that other one where we were like, there's that other one? Can we just cheat and use it even though it's not on the formula sheet? If I promise you that I will never ask you a test question on this particular formula. This formula will really work very well on this question. It says if you want to sum a mysterious number of terms, you can take the first term in the numerator, first term minus the nth term times r, and divide that by 1 minus r. So if we go ahead and use that formula, we have all the clues we need. If you guys wanted to use a different formula, or if you wanted to use sum of the sequence, you would have to go and figure out how many terms you were adding up there because you don't know n. We could find it, I just don't want to. So the nth term is this guy, so you're going to put that there. First term is 8, so you're going to put that here. And then common ratio is clearly a 1/4. Put that there and there. So in our calculator, we're going to need to open a parenthesis, and then we're going to type 8 minus 0.03125 times our common ratio of 1/4. There's no powers on it, so you don't need additional parentheses there. But you do need to close your numerator. And then you're going to divide it by, use parentheses or do some mental math, 1 minus 1/4. Even if you simplified that to 3/4, which it is, you would have to put 3/4 in parentheses when you divide by a fraction. So keep that in mind. Type, y'all. It's like 74 something. No? No, I'm on the wrong question. 341 over 32? Okay. Beautiful. Any typing issues? Okay, cool. So if that shows up on your homework, please do use that formula just for the sake of easiness. I promise not to give you something like that on a test where I wouldn't give you the formula to use, okay? No? You got that face that I screwed up. What did I screw up? Neither of you match me? Well, that's a shame. Well, it's probably me. All right, make sure you open a parenthesis, and then 8 subtract 0.03125 times 1/4, close the parenthesis. Make sure you hit a division sign next. And then open another parenthesis, 1 minus 1/4. Did you hit math enter? It should bring you back to 341 over 32. Or else I'm wrong. All good possibilities. You got it now? All right. It's the moment of truth, senior. It's her shining moment. Everyone watch her type. Everybody watch her type. You didn't do math enter?
No, I was right the first time.
Oh.
Yeah, so I did it wrong. Yeah. I forgot the ones.
It's okay. You're fine. You forgot the parentheses? Is that what you said?
The first sentence.
Oh, that'll do it. Okay. Yeah. All right, so this next one, we have this sigma notation, which sigma notation is like begging you guys to use sum of the sequence because it literally gives you the sequence formula right there. So if I was on a test and this was my question, there's no ifs, ands, or buts about it, guys. I would just do sum of the sequence. So your sequence formula is right there. Make sure that you guys are practicing typing this because you have to put the n minus 1 in parentheses. If you're in function mode instead of sequence mode, you have x's. It doesn't matter. It works the same way. And then notice that on the sigma notation, they want you to start at 1 and go to the 11th term. All right. This is the one where the answer comes out to 74 point something. So 74.8582. Did anyone get a fraction when you hit Math Enter? Apparently I didn't bother. But it doesn't nicely go back. Okay, then just leave it. All right, this time they want the first 16 terms, so it's a finite series. Oh, and it's recursive, so womp womp. I'm not going to be able to use some of the sequence right now, and that's okay. I could put it into a table, yeah. Yes. You want to do that? You want to write it as an explicit formula? That a girl. That's exactly what I was going to do too. Great minds think alike. Okay, so what can you kind of translate what this sequence is saying though? It says to take -2 and multiply it by your previous term, right? That's what it's saying to do. So if we want to think of this in geometric form, the previous term, the starting value, it has to be that first term, so 1. And then because you're going to multiply by -2 each time, that's your common ratio. So they're kind of like telling you the common ratio, huh? And then to the n-1 power, of course. The 1 doesn't really do anything, so if you want to drop it from the formula, you sure can. So now, because we have an explicit formula, you're welcome to use sum of the sequence. So you can do sum of the sequence because you now have an explicit formula of, watch the parentheses usage here, guys. -2 has to be in parentheses, as does the n-1 power. Notice I didn't put the 1 in front because it doesn't matter. And then comma n, comma 1, comma 16. Now, if you don't like that method, what you could have done was you could have found the 16th term. Well, actually, no, you don't have to. What am I thinking? You could have used that new formula, the one that is on your formula sheet, the one that's really hard to type in. Are you guys getting that impression? That formula is a pain in the tushy to type in, the weird fraction one with all the parentheses. So that formula would have been 1, and then this first set has to be in parentheses. I always forget this formula too. 1 minus the common ratio, which has to be in parentheses because it's got a negative on it, to the 16th power, close your numerator, divide it by 1 minus -2, which you can just call a 3, but it is a quantity, 1 minus -2, if you don't simplify it. So either way, you should get the same answer of -21,845. Anyone having typing issues? Speak now, or forever hold your peace. It's very dramatic for a math question, wasn't it? All right. Oh boy. I see sigma, I see think about it, and I see sigma. Let's talk about them. Because this is an infinite sequence, they want me to add up to infinity. Well, that's going to be fun. I can only add up to infinity if my common ratio, the absolute value of it, is less than 1. So here's your common ratio, guys. Is 3/8 less than 1? Sure is. That means you get to use your formula. We decided sum of the sequence, it has a heart attack and it stops working, so don't do that. The formula for infinite, and that's the notation I want to see, so sum for infinite would be a sub 1. Who's your first term? It's staring at you if you look carefully. 13, good. And then you're going to divide it by, use parentheses if you're on one step on your calculator, 1 minus the common ratio. Even if you converted that to 5/8, simplified it to 5/8, you still have to use parentheses there. What'd you get? 20.8. I hope. Okay, cool. Otherwise I've had the wrong answer on my key for years. Alright, number 10. They don't flat out tell me a formula, so we have to finagle this. First of all, let's figure out if the common ratio is appropriate for using an infinite series. So what's your common ratio if you took the second number divided by the first number? Yeah, it's a half. So since the common ratio is smaller than 1, we're allowed to use an infinite sequence formula. So add them all up, same formula. This time the first term is just right there, 10. And we're going to divide it by the quantity 1 minus 1/2. Again, if you went ahead and said that was 1/2, you still have to use parentheses if you're typing in your calculator, but you should get a 20. And then look at this next one. What's your common ratio? It's a 3. Doesn't that kind of violate the rules? because this one's just going to get bigger and bigger and bigger and bigger off to infinity. So you're just going to say it's not possible. The limit does not exist if you looked at that sequence. So therefore I can't infinitely sum all the terms because I'd be doing it forever. Oh, finally some fun applications. So accounting. Oh, tomorrow is AP Chem, right? In the morning? Who's going to AP Chem tomorrow? All right, so what we're going to do tomorrow is a whole bunch of these application questions, and that's kind of it, but I'll be sure to record it for you. The ones that are on your test for applications are like the theater question where there's, 4 more seats in every row. That one's on there. There's also a question coming up about, we're going to see it in a minute, about exponential growth and decay and what that looks like. All right, so each year a car value depreciates 18%. If you bought a car in 2009 for $22,000, what's the value in 2015? This feels really familiar. Like you did a whole bunch of these for me. In fact, you did a whole bunch of these for your Algebra 2 teacher. Do you remember doing the depreciating values of things? It was an exponential decay question. So now we have to kind of shift our thinking over to how can I apply that to the geometric sequence? Because that's really what it is. So when you bought the car, instead of calling this the first term, I like to think of this as the 0th term. Like that's the initial purchase value of the car. You haven't made any payments on it. It hasn't depreciated yet. Nothing's happening. It's $22,000. So we're pretending like time starts in 2009. So forget what you know about this n-1 that goes up in the exponent for the geometric sequences, because, and we've discussed this before, when I look at this formula, it's a little misleading because whatever this subscript is, this should match it. So like we just kind of all agree in math that we should always start with the first term of a sequence because it just makes sense if you have a sequence. But if I start with the 0th term, guys, how does it change up here? Well, what would n-0 be? Just n, yeah. So that's what we're going to see in a minute. So if you were back in Algebra 2, you guys would have written an exponential decay graph for me. But now that we're in geometric pre-calc lesson, we're going to call it a sub n equals, now the 0th term is 22,000. What about our common ratio? If it depreciates 18%, that's like 1 minus 18%, better known as 82%, so 0.82. And then I'm going to call it to the nth power. I'm not going to use n-1 because we're not starting with year 1, we're starting at year 0. So that's a little confusing. It's all with how you frame it. I could have called this a sub 1 and kept it as n-1, but then I'd have to think really hard about what time means in that question. I just didn't want to do that. So guys, if time starts in 2009, how many years have elapsed? 6 years, isn't it? Throw a 6 in there for me. So the car is worth like $6,000, and it's money, so you want to round appropriately. $6,688.15. Cool, cool. So that was kind of like very reminiscent of something we've seen before. And I hope I didn't confuse you extra because of the weird nth power instead of n-1. All right, so this one. I love this question. Florida's population grows 23.5%. Okay. I feel like this isn't really feasible. It's not going to grow 23.5%, whatever. The population in 2000 was that. What's going to be the... If this rate of growth continues, what will be the approximate population in 2030? It's a horrible thought. You know that Facebook thing where they're like, Google your name with like Florida? Florida man, yeah. Those crack me up. All right, we don't want to talk about that. I don't want to offend any Floridians out there. All right, so first of all, guys, be careful. This is, how much time has elapsed here? 10 years, which we can just call a decade if you wouldn't mind. Are we okay with that? So it's growing 23.5% per decade. Are you okay with me saying it that way? All right. So the initial population is this number. And it's going to grow. All right, so we got to multiply that by 1 plus 0.235, so 1.235. But guys, how many decades are going by here? From 2000. 3 decades, huh? So I don't want to rewrite all this, but you'd have to type this in your calculator. Yeah, I know. Oh, and my answer's like way wrong because I put 30 years in like a silly pants. I misread the question the first time I did it. I didn't realize. I thought it was growing per year, and I thought that was hilarious. It's per decade. It's still a pretty big number. I need to scribble out mine. Okay, keep going. What'd you get? Wait, I'm sorry. One more time. 39. Oh. 309. 301. 052. 52. Ish. Okay, so we don't, yeah, ish. So, oh boy. Good luck, Florida. That doesn't seem right. Okay. Well, we're out of time. So tomorrow we'll start with that salary question, but you guys should be able to do your homework, okay? I know, the bell. Ah. All right, good luck.